Okay, oneness coordination theory already I have explained. Now you can write from this. These are the main points. The main points of this theory are: in complex compounds, the central metal atom or ion exhibit two types of valency, that is primary valency and secondary valency. Primary valency means the oxidation number of the metal, and secondary valency means the coordination number of the metal. Second point, primary valency is satisfied by only negative ligands, I mean anionic ligands, and secondary valency are satisfied by both neutral and anionic ligands, I mean negative charge ligands. Number 3, the secondary valencies are always directed towards the fixed positions in space, which gives a definite geometry for the complexes. These are the main 3 points of oneness coordination theory. I mean, when you write the formula of a complex, you have to maintain both the primary valency and secondary valency. In every complexes, the central atom exhibit two valency. One is called primary and one is called secondary valency. Primary valency means the charge of the metal, that is called primary valency, and secondary valency means the coordination number of the metal, I mean how many bonds present with the metal. When you determine the primary valency, I mean when you determine the charge of the metal, then there is no contribution of the neutral ligand, and that is why primary valency is satisfied by only negative ligands. But secondary valency, when you determine, you have to consider both the neutral ligand and the anionic ligands, and that is why secondary valencies are satisfied by both neutral and anionic ligands. And the third point, to maintain the secondary valency, when the ligand comes towards the metal, the ligand always comes with a direction. In a proper direction they will come, and that is why the complex always have a definite geometry. For example, if the coordination number is 4, the shape may be the tetrahedral or maybe the square planar shape, and if the coordination number is 6, then the shape of the complexes will be octahedral. So that you have written in the third point. The secondary valencies are always directed towards the fixed positions in space, which gives a definite geometry for the complexes. So this is about the coordination theory. Now we will do another topic which is called bonding. I mean bonding in coordination compound. Bonding in coordination compounds. VBT, valence bond theory. By applying valence bond theory, we will explain about the bonding in coordination compounds. So according to valence bond theory, when the ligands produce the bond with the metal, as you know, all the bonds are dative bond, coordinate bond, because ligand donates the electron pair. Metal have no contribution of electrons to forming the bonds. So that is why the electrons come only from one side, and that's why this type of bonds are called coordinate bonds, and that's why the compounds are called coordination compounds. Now according to valence bond theory, when the bonds produce in between the metal and the ligand, and when ligand donate the pair, the metal will accept that electron pair. So to gain the electron pair by the metal should create some vacant orbitals. So before gaining the electron from the ligand, metal will produce some vacant orbitals. After production of vacant orbitals, they will form some hybrid orbital. I mean they undergo hybridization, metal undergo hybridization, and it will form some hybrid orbital. After forming the hybrid orbitals, the ligand will donate the electron pair to that vacant hybrid orbital. So that is why when a complex compound is formed, before forming the bond, the metal undergo hybridization, and after hybridization they will form some hybrid orbitals, and in that hybrid orbitals the ligand will donate the electron pair and it will enter in the vacant hybrid orbitals. Now when a complex is supplied to you, you should know what type of hybridization shown by the complex. If you can find out the type of hybridization, then you can find out their shape then you can find out their structure also. For example, if some metal shows sp3 hybridization, then the structure of the complex will be tetrahedral. If some metal undergo dsp2 hybridization, then the shape of the complex will be square planar. And if the coordination number is 6, then the metal undergo either d2sp3 hybridization or sp3d2 hybridization, then the shape of the complex will be octahedral shape. So I will show you one example. One example for sp3 hybridization, one example for dsp2 hybridization, one example for d2sp3, one example for sp3d2. So you should know how to find out the hybridization state of the metal. If you know how to find out the hybridization state of the metal, then you can find out their structure, what type of structure contained by the complex. And secondly, you can find out the magnetic property also, whether the complex will be paramagnetic or diamagnetic. After hybridization, if the metal contains some unpaired electron, then the complex will be paramagnetic. And after hybridization, if all the electrons in the metal are paired electrons, then that type of complexes will be said to be diamagnetic one. So if you know about bonding, if you know about the type of hybridization, you can find out the structure of the complex, you can find out the magnetic property of the complex also, whether the complex will be paramagnetic or diamagnetic one. That's why in exam the question will ask like this: this complex is tetrahedral, this complex is square planar, explain. So to explain that, you should find out, you should know how to find out the hybridization state. Your answer should be like that: this one undergo sp3 hybridization, that's why its structure is tetrahedral, but this one undergo dsp2 hybridization, that's why its structure is square planar. So like that way you have to explain. Similarly, one question asks, this complex is paramagnetic in nature, this complex is diamagnetic in nature. To show that, if you want to find out it, this complex is paramagnetic due to presence of unpaired electron, and this complex is diamagnetic due to presence of all paired electrons. But you have to show it, how it contain the unpaired electron, how it contain the paired electron. So that is why this bonding is very important, and from this bonding in coordination compound, number of reasoning questions will ask in your exam. So to apply the proper reason, you should know about the bonding. Thank you.